Home prices in a certain community have a distribution that is skewed right. The mean of the home prices is 498,000 with a standard deviation of 25,200. Suppose we take a random sample of 30 homes in this community. What is the probability that the mean of this sample is between 500,000 and 510,000? Right, so we are going to start here, as we did with our other problem when we were doing our central limit theorem, by listing things that we know. So our population is all homes in the community. Our sample size was 30. 30 homes were sampled. Our mu, our population mean, so the mean price of these homes for all homes in our community was 498,000. And the standard deviation, our sigma, was a 25,200. What we want to know, what is the probability that the mean of the sample is between 500,000 and 510,000? So again, using our notation that we used previously, all right, our capital P for probability, and we are between 500,000 and 510,000. So we're going to write this using proper notation. Again, so we start with 500,000 is less than or equal to x bar, which is our sample mean, less than or equal to 510,000. Right? And that's how we're going to enter it eventually into StatCrunch as well. All right, so our sample is random and independent. Yes, it is. Our population is at least, or excuse me, not our population, our sample size is at least 25. Yes, we have a skewed right population, but our sample size is large enough. So we'll say population is skewed. But our sample is greater than or equal to 25, so we are okay. All right, all homes in the community. Greater than or equal to 10 times 30, which is 300. We will assume, again, since we're not told otherwise, that there are at least 300 homes in our community. Right, so now we need to find our normal distribution. So we're going to start by finding our standard error. So our standard deviation was 25,200 divided by the square root of our sample size, so the square root of 30, and that gives us 4,600.87. Right, so our normal distribution is represented by the mean of 498,000 and then a standard deviation of $4,600.87. All right, so now we are going to again go to StatCrunch to finish this off. I am going to go ahead and draw a sketch. So again, our mean was 498,000. We were between 500,000 and 510,000. So that's going to be roughly from somewhere about here to about there. We're going to shade these in. Again, previously when we were doing our central limit theorem problems, I was taking more time labeling our axes using the empirical rule, which you can definitely still do, but it's not really necessary at this point if we can kind of guess where it's going to be using our knowledge of our picture. All right, so we're going to StatCrunch. Again, we are going to use our normal calculator, and then the information that we're going to plug in. Right, our mean is that 498,000. Our standard deviation, remember it's not our original standard deviation, it's the standard error, so 4,600.87. And what we are entering in is that our value is between, so we do have to check the between part when we're doing this in our normal calculator, 500,000 and 510,000, and that is going to, if we get a value and we round it to 3 decimal places, 0.327 after we compute that. So we can write out our answer in a sentence. the probability that the mean sample price is between 500,000 and 510,000. Is about 32.7%. So another problem that we have worked through using our central limit theorem, again, we make a list of what we know, we check our conditions, we find our standard error, and then we go to StatCrunch then to find our probability.